This section has lots of notation. Okay, so I know you've seen me write this before in calculus. So when you put the double bars there by the R, that's a way of saying all real numbers. So Z, if it's not bold, like in a textbook, you write it like this with the double bar for the Z, and that stands for integers. So integers, -2, -1, 0, 1, 2, right? All those numbers. So integers include 0. Integer, the letter Z comes from the German word Zahlen. All right, Q. The Q stands for all rational numbers. So Q stands for rational, and it's all quotients of integers. So 3/2, 2, because that can be written as 2/1, right? Anything that can be written as a fraction. Natural numbers, so that's the double bar there. If you don't want to write the big bold face, so that's all non-negative integers. So counting numbers, as you can think of them. Okay. So if you put the Z with the plus, that means all positive integers. So 0 is neither positive or negative. That's a big deal. So it's something you just need to kind of keep in mind. And so this X with this little sign here, and I'm going to write it like this, whoops, like that, element of, right, trying to make a nicer one, there we go, like a little E, element of, so X is an element of the negative reals. Right, and remembering that 0 is not positive or negative. So this sign right here, and how we write it, you can write it like this, or you can be specific that it goes in like this, but this means for all. So this is universal, for everything. So universal statements are really powerful, so it holds for every element in the domain. So this is a way to say a universal statement. For every X in D, comma, Q is happening, right? Whatever the Q is, okay. So determine whether these are true or false. And if it's false, give me a counterexample. You don't need to prove it's true, but if it's false, give me a counterexample. So for every X in the real numbers, X squared is always bigger than or equal to X. I think that's false. So my counterexample, if I'm showing if I use X equal 1/2, I get 1/4 is not greater than or equal to 1/2, right? Okay, so that's not true. So for every n in the natural numbers, so that's the counting numbers, 1, 2, 3, 4, is it true that n squared is bigger than or equal to n? Yes, that's true. So is it true for all reals, for every x in the reals, that x is divisible by 1? Yes. And we're not proving true things. We're just wanting to make sure you can give a counterexample if it's false and just establish whether it's true or not. For every n in the integers, 1/n is in the reals. For every n in the integers. Every n integers, n equals 0 is in the integers. N equals 0 is in the integers, but 1/n is not, so n equals 0 doesn't work. Okay, so this is false. Okay, ooh, look at all these letters. So for every p that's in the positive rationals, so positive fractions, if I know that p is bigger than 1, then 1/p will be smaller than 1. I know p is bigger than 1, so it could be 4 or 3/2. Is it true that 1/p will be smaller than 1? Yes, that is true. So again, not necessary to prove it. We're just looking to see if we can establish what it's saying with the new notation.